Okay, Assalamualaikum warahmatullahi wabarakatuh. I will continue with our chapter 2, which is previously we did cover on chapter 2, 2.1 and 2.2. In 2.1, I did mention about the purpose of latex being produced, concentrated latex being produced. And then the chapter 2.2, I did mention about the method that commonly applied by prepare a concentrated latex are divided by 3, which is we have today we will cover on creamings and the evaporation process, and the lastly is the huge industry that being used is centrifugation process. So let's continue with our today topics. So 2.3 is a concentration by creaming process. What is a creaming process? Creaming process involves of feed latex, which is ammoniated at 0.7% weight over weight on latex. So you need to check the ammonia content during the reception, and if your latex has high magnesium content, you probably need to add some phosphates in order to precipitate the magnesium as a slush. So during the reception, usually we add some phosphate, and then we'll allow it to rest approximately overnight, and this precipitate magnesium will slush, and we can easily remove the precipitated magnesium. And then we add the creaming agent and ammonium alginates. Okay. And then for master batch process, usually involved with 2 portions. The first one, we take approximately 12% of the latex from the bulk. So you need to measure the total amounts of your latex, and you take approximately 12%. You add ammonium alginate, which is 0.1% weight over weight on total crops of the RC. So all you need to do before doing this creaming process, you need to measure the DRC. DRC measurement be covered by our experimental methods. Okay, and then the portion 2, we take out approximately 6% of the latex from the bulk, and then we treat it with 70% of ammonia oleates at 0.05% of weight over weight of total crops, and then we add portion 1 and 2 in the bulk latex. We stir for approximately 2 hours for complete mixing. So all you need to do is preparation of portion 1 and portion 2 before you add to your bulk latex. The bulk latex is then clarified using a centrifuge or by filtering to remove a phosphate slush. Okay, previously we did add some phosphate to remove significant amounts of magnesium, so you need to remove the phosphate slush also. So ammonia latex is again adjusted to 0.7% weight over weight of latex. So after the initial process of measurements of your ammonia content, so after the additions of the portion 1 and portion 2 onto your bulk latex, you need to measure the ammonia content again. If it reduces, usually it will slightly reduce from the 0.7% that required, so you need to add some more ammonia. And then the bulk latex is heated by live streams to 40 degrees Celsius to optimize the creaming process. And then the bulk latex is allowed to stand in the main creaming tank for approximately 20 hours. Okay, so after 20 hours, the 40% of bulk latex is drained off, which is the skim latex contain approximately 2% of DRC. Carry out the quality control test on the skim latex, VFA and TSC. And then the second day, latex received on the it is treated in the same way and pumped into a same creaming tank from step 1 to 8 are repeated. So this is a long process for creaming process. I think approximately 1 week before you can actually start the creaming process. Okay, the two crops are allowed to cream together. 40% of the second day volume is removed after 20 hours of creaming. This process continues for 8 to 10 days until the creaming tank is full with 60% of total crops over the period. Okay. So this is the illustration of latex separation after approximately 168 hours, which is 7 days, equivalent to 7 days. So upper layer is the DRC, and the bottom layer will be actually there is a middle layer which is the mixture of the rubbers and the serums, and the bottom layer will be your serum. And then the cream latex now contain about 50% of the RC, and the bulk is left undisturbed for approximately another 3 weeks to complete creaming. Okay, so you don't stir, you don't add any motion to your tank, because we don't want to disturb the cream process. So we don't want to mix the cream latex with the serum. And then after this, you remove 30% of the latex from this bulk. The skim latex contain about 4% of the RC. The original cream latex contain about 66 to 68% of the RC. So since the main cream tank has a large diameter, a diffuse fraction will occur. So this is the illustration, okay, where the cream's latex or the cream, the RC, approximately 67% will be on the tops of your tank, and then we have diffusion, which is here is contain the RC and your serum, and another 30% will be your skim latex, which is approximately 4% of the RC. The fraction between the skim and the concentrate latex, this diffuse is run off separately into narrow funnel bottom secondary creaming tank, and is allowed to cream for 2 weeks. Okay, so after 2 weeks, 40% of skim latex is removed. The cream latex is added to the main bulk in the storage tank, stir for 1 to 2 days to ensure homogeneity. The main bulks of the cream latex concentrate is treated as step 19, and finally, the alternate methods to produce a diffuse fraction. Skim latex recovery, usually you add ammonia alginate for creaming coagulation process into a pale cream. This is about 2 to 3% of the original crops. And for the properties of cream latex concentrate, usually we will gain the higher DRC compared to centrifuge latex. Okay. However, smaller rubber particle will be produced as compared to centrifuge evaporation process. TAC and the RC difference is slightly smaller, although there is difference, but it is much smaller as compared to centrifuge method. Whereas for evaporation process, TAC and BRC usually similar. And then KOH and VFA number is good, and MST is very good, which is very high MST. Okay, so that's all for 2.3. Before we continue with 2.4, there is wise word for this session, which is I will always say that you need to aim for the moon, because if you miss the moon, you may hit a star. So please think about it. So please aim higher so that you can achieve whatever you want to achieve. Chapter 2.4 is a concentration by evaporation process. I think this is very simple process. Previously, I did cover on concentration by creaming process. For evaporation process involve the latex which is fed into tops of heated vertical tube by a side inlet. Okay, a central rotor with plate through a latex against the walls of the tubes, and then the latex spiral downwards. Water will evaporate it. So this is the whole process of evaporation process. So you remove the water by evaporating it during the process. Vapor is drawn out of the tops of the tube. The clearance between the blades and the tube wall is only about 1 mm, so that only a thin turbulent layer of latex is in contact with the wall. So that actually the thinner the clearance, the gap between the blades and the wall will provide a better surface area, and the evaporation process will be more effective. So this is the illustrations of we have the whole process of evaporation process. So basically latex will be fed in here, and we will come out of down here via gravitational force to produce a latex concentrated. And then we have this evaporator, we have a heating medium outlet and heating medium inlet. So the water usually either water or any solvent will be used as a heating medium to increase the temperature, so that you can evaporate significant amounts of water in latex. So over here, the evaporation time is no more than 20 seconds to reduce the possibility of degradation. So usually from the inlet to the outlet of the evaporator machines usually takes approximately 20 seconds only, because the higher latex contacts with the heated wall, it will start to degrade, and once your latex degrades, you need to remove it. And then the concentrate from the bottoms of the tube is preserved with potassium hydroxide. And then for the characteristic of evaporate concentrate latex, usually the latex contains essentially all its original non-rubber, full range of particle size, efficiency is visually 100%, excellent stability and permeation properties, and basically these types of process produce a concentrated latex for carpet backing, binder in road surface, and latex threads, because of the TSC is quite good. So it will be used as a binders or latex threads. The advantage of evaporation process, usually the high rubber and non-rubber content, because this whole process actually did not remove any other non-rubber content. It's only remove a significant amounts of water, so that the content of rubber and non-rubbers still high. But the disadvantage, the stability of final latex is not good as centrifuge latex, because it involves heating process, and then it's not suitable for manufacturing rubber article which require less rubber content. So usually only specific final product require evaporation process, because it require high rubber content. Usually this is the method that produce higher DRC and TSC. Okay, so by that wise word from Saint Jerome, it says that good, better, best, never let it rest until good is better and your better is best. So you need to know when to stop, so that you can achieve a better you can achieve what you aims in your life. Okay, that's all from me. So we will continue our next session on the last concentration method, which is the centrifugation. By that, sekian, Assalamualaikum warahmatullahi wabarakatuh, and goodbye.